Since time immemorial, humans have looked up at the stars and wondered, how did it all begin? Where did the universe come from? Today, we embark on a journey to explore the origins of everything, the birth of the universe, as explained by the most widely accepted scientific theory, the Big Bang. The Big Bang theory is the prevailing cosmological model that describes how the universe expanded from a highly dense and hot state. This isn't just a wild guess, it's a theory grounded in a wealth of observational evidence. But what exactly does it entail? Imagine all the matter, energy, space, and even time itself compressed into a point smaller than an atom. This point is what we refer to as a singularity. Around 13.8 billion years ago, this singularity began to expand. It wasn't an explosion in space, but rather, space itself was expanding. This expansion is what we call the Big Bang. But how do we know that this theory is correct? Let's dive into the evidence. First, there's the redshift of galaxies. In 1929, Edwin Hubble observed that galaxies are moving away from us, and the farther they are, the faster they're moving. This led to the understanding that the universe is expanding, which aligns perfectly with the Big Bang theory. The second piece of evidence comes from the cosmic microwave background radiation. This is the afterglow of the Big Bang, faint, nearly uniform radiation that fills the universe. Discovered in 1965 by Arno Penzias and Robert Wilson, the CMB provides a snapshot of the universe when it was just 380,000 years old. It's like seeing the universe as a baby right after it was born. Finally, we have the abundance of light elements, hydrogen, helium, and lithium. The Big Bang theory accurately predicts the relative amounts of these elements found in the universe. The fact that these predictions match what we observe is a strong indicator that the theory is correct. Now that we understand the basics of the Big Bang, let's take a closer look at the timeline of the universe's birth and early development, the Planck epoch. This was the first fraction of a second after the Big Bang, where all the fundamental forces, gravity, electromagnetism, and nuclear forces, were unified. It's a period we know very little about because our current physics can't describe the conditions present at that time, the inflationary epoch. In the next tiny fraction of a second, the universe underwent rapid expansion, much faster than the speed of light. This expansion smoothed out the universe and laid down the seeds for all the structures we see today, like galaxies and clusters of galaxies. Recombination. About 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to combine and form hydrogen atoms. This allowed light to finally travel freely through space, and this is what we see today as the cosmic microwave background radiation, the formation of stars and galaxies. Over the next hundreds of millions of years, gravity pulled hydrogen gas together to form the first stars. These stars grouped into galaxies which continued to evolve over billions of years into the vast cosmic web we observe today. Despite its widespread acceptance, the Big Bang theory is often misunderstood. Let's address a few common misconceptions. First, the Big Bang wasn't an explosion space. It was the rapid expansion space itself. There was no center of the universe from which everything expanded. Another common question is, what happened before the Big Bang? According to our current understanding, this question may not even make sense because time itself began with the Big Bang. Asking what happened before is like asking what's north of the North Pole. It's a concept that doesn't apply. It's also worth mentioning that the Big Bang theory doesn't explain the universe. It describes how the universe evolved from an early, hot, dense state. The question of why there was a Big Bang or what triggered it remains one of the biggest mysteries in cosmology. So, what does the future hold for our universe? The fate of the universe is tied to its expansion. If the universe continues expanding forever, it could end in where stars burn out, galaxies drift apart, and the universe becomes cold and dark. Alternatively, if gravity eventually overcomes the expansion, we could face where the universe collapses back into a hot, dense state. There's even a third possibility, where the expansion accelerates so much that it tears apart galaxies, stars, and eventually, even atoms. While we don't yet know the ultimate fate of the universe, what we do know is that the Big Bang theory has fundamentally changed our understanding of the cosmos, offering a glimpse into the origins of everything we see around us. The story of the universe is a story of change, of a cosmic journey from simplicity to complexity, from nothingness to everything. And as we continue to explore, who knows what other mysteries we'll uncover? Thank you for joining us on this journey through time and space. Be sure to like, subscribe, and stay curious. Subscribe for more cosmic content.